And welcome back.
All right, so actually I think we can probably, because I don't think that's one of the ones. Let's go down to some of the ones you guys were encountering with our questions. So let's go down to example 5. We can skip example 4 for right now.
Okay, I believe you.
Andy's crying.
Jackson, did you win?
Yeah.
All right. So guys, in this case, we're going to distribute. So in example 5, if you want to jump ahead to that one, we're going to distribute in the 2. And a few of you guys encountered these types of problems when we were working outside. So in this case, what are you going to do next?
No solution.
So how do you know it's no solution?
Because they both have the negative 2.
I found a solution.
Well, we didn't do it right then.
Okay, so the negative 2k's are going to cancel on each side because they're the same. So they would cancel out. And so we end up with 10 is less than 1. Is that a true statement?
No.
No. So that means that's not the case, and that means nothing can ever work in this problem. So this one's considered a no solution. So if you wanted to graph it, the graph would be the most boring graph ever, so you don't really have to graph it. It's no solution. There's no answer that works for this. So this one's no solution. Just kind of watch out for those. It's the other thing other than multiplying and dividing by a negative that makes these a little bit more tricky. All right, let's go to this next one. Okay, so we're going to distribute here and here. We distributed. Now we can combine some like terms. And some of you guys might have started having some kind of ideas of what's going on here. So 42 minus 24 is actually 18 as well. So I have the same thing on both sides.
No, it's multiple.
So if I go to subtract the 12m's, I get 18 is less than or equal to 18. Is 18 less than or equal to 18?
Yes.
Yeah. Or 0 is less than or equal to 0. Any of those things. The or equal to makes this one work. So if I have something like this, this is going to be infinite solution. So any number I put in for m is going to work. So we can do this little fancy symbol or IMS.
Oh.
In this case, the same thing would be as if I had like 0 is less than 5. That's a true statement. So any circumstance that's a true statement, but it really doesn't tell us anything about the value of the variable, that's when we say all real or infinitely many. So on the number line, absolutely everything works. So you could just say all real, infinitely many. So saying to graph it, I guess, is kind of silly, but you could. All right, we'll finish up with this last word problem here. And then I'll give you some time to work on homework. So Andrea has a budget of $115 for printing. The service she uses charges $25 to activate an account. So just to go to the place, she's got to pay $25. So kind of like a membership. And every time she prints, she gets charged 8 cents per page. How many pages can she print and stay within the budget? They want us to write and solve an inequality. So we do want to write it out, showing kind of how we're coming up with this. So 25, and you said what?
Plus.
So let's stop there for a second. So 25 plus. So she's got to pay $25 upfront just to belong to this place, or maybe get a key fob to get in, or whatever it happens to be to get her set up in the system. So $25 is kind of the fee just to get in. But then every time she prints, she gets charged 8 cents a page. How would we include that in our equation here? Go ahead, Ethan.
0.08x.
So yeah, every page she prints, she gets charged 8 cents. So 1 would be 8 cents. And she has a budget of $115, and she wants to stay under budget because her boss would be mad if she went over that budget. So what inequality are we going to use? Less than? I guess we could probably do or equal to, I guess, because she has that budget. So we could go or equal to, I guess, $115.
This is the less than, this is the or equal
Oh.
And so now we should be able to solve this. So being able to set up this inequality, especially on a test like an ACT or something like that, ACT loves to make you set up equations and maybe not even solve them. So knowing how to set up an equation, this is a pretty common one. So we move the 25 over, 8 cents. So there I get 90, right?
to. Yeah.
Divide by 8 cents. So I'm left with $90 still to print. Divide by 0.08, and we end up with quite a few copies. What do we get? Like 11, 25, is that what we got? All right, questions there at all? Okay, so homework is listed there for you guys. I don't think there's any weird ones like the last one where you shouldn't be able to do them, but if there are, if you ever get like she didn't show us one like this or something like that, you can always shoot me an email or just skip it for now. It's okay. Yeah. All right, thanks. Have a good weekend.
Put your mask up in the hallway.
Yes, Jack's mask. Thank you.
Like,